Hello, this is Kato Thomas, doing a Bachelor of Science in Software Engineering. I'm here presenting my project. Yes, so my project is the Students' Result Prediction Project. These are the contents of the presentation that I'm about to make. We'll start with the problem, the data that I will be using, the features the data that has, the Bayesian theorem, the naive Bayes, the Bayesian networks, and so on. So description of real-life problem to be solved with the AI. The problem I want to solve is the problem of students not having enough guidance, not having a straightforward path to use as they are having their education. And such a problem can lead to an increased number of people who look at themselves as failures. And it also leads to a high level of unemployment, can also lead to a slow pace of the development of our economy. So the data set that I will be using to solve such a problem, I would use a data set that has information about students' performance. The data set that I'm going to be using is from UCI Machine Learning Repository about student performance. It has in different attributes for student. For example, their attendance records, their previous marks, the failures, the sex and the age, and so on. I'll be using this data to solve this problem in my AI project. The factors that I considered when I was selecting the data set were the size of the data set. I believe that the larger the data, the greater the more you explore from the data, the more the algorithm gets to learn, and the easier and the more efficient the operation of the algorithm is. Second, I talk about the reliability of the data set. Reliability greatly depends on the source where you got the data set from, and it will also affect the accuracy of your project. Also, the data must be well structured and easy to read. This is easy. This can lead to easy usability of the data that is to be used by not only the algorithm, but also the creator of the algorithm. Then the problem to be solved. Different problems deserve different solutions. So I would first look at the problem that I'm going to solve, and then I would come up with a solution that is according to that problem. For this problem, I'm looking at students' performance. So the data set that I would use is towards students' performance. The features of the data set that I will be using are, I would be using the first period grade, which is named G1. It's a numeric data column that consists of marks scored by students in the first period. The second period grade, named G2, is a numeric data column that consists of marks scored by students in the second period. The weekly study time, named as study time, is numeric data that consists of numbers from 1 to 4, corresponding to a range of how many hours are spent studying weekly. For example, let's say if someone studies for less than 2 hours a week, that would correspond to 1. Someone studies for more than 2 hours, 2 to 4 hours, that would correspond to 2, and so on. Then the past failures of the student, if someone has failed in the past in a certain class, then I would also be using the final grade, which is named G3. And the final grade would actually be predicted by the algorithm. And so I'm also talking about the Bayesian theorem. The Bayesian theorem is one that is used to determine the probability of an event in cases of uncertain knowledge. It is used in terms of conditional probability. It was named after a British mathematician named Thomas Bayes. The equation shows here below, probability of A given B is equals to the probability of B given A multiplied by probability of A divided by probability of B. So according to the Bayesian theorem, probability of A given B is known as a posterior read. It's known as a posterior, which is read as the probability of the hypothesis A when evidence B has occurred. The hypothesis is A, and B is the evidence that is used. Like A happens when B has occurred. Then we have the probability of B occurring given A is the likelihood in which the hypothesis is true. Then the probability of A is the probability of the hypothesis before considering the evidence. Hypothesis is like assumption event. That's what I would call it. Then the probability of B is known as the marginal probability, which is the pure probability of an evidence, which is, let's say, you can use Bayesian theorem for assuming a certain event. For example, if someone likes a certain movie, they would know certain things about this movie. For example, they would know the names of the characters. You would use such information to, based on your hypothesis, to know whether it's true or not. More about the Bayesian theorem. The Bayesian theorem is applied in several artificial intelligence systems for probabilistic or Bayesian inferences. So a Bayesian inference is a method of statistical inference in which the Bayesian theorem is used to update the probability of a hypothesis as more information becomes available. As I said before, someone can get to know whether they like a certain movie or not based on whether you know the names of certain characters in the movie, whether you use certain slogans that were used in those movies. Someone can use that information to know whether a certain hypothesis is true or not. That's what I would call an inference, basing on something in order to use that information to know whether something is true or not. So the Bayesian theorem can be used to calculate the next step of a machine when the already executed step is given. Because with the Bayesian theorem, if you want to get the probability of A given B, you can use the probability of B given A to get that probability. To get it's a whole formula. Yeah. Then so the Bayesian theorem is also applied in weather forecasting systems. Yeah. Okay, again, I'll clarify that if you want to get with the Bayesian theorem, you can get the probability of A given B once you know the probability of B given A. Yeah. Then the naive Bayes algorithm is a supervised learning algorithm based on the Bayesian theorem that is used for solving classification problems. For example, if you want to classify between whether we can play in the sunny weather or not, you can use the naive Bayes algorithm. The naive Bayes algorithm actually it uses the Bayesian theorem in its calculation, because you can use the naive Bayes algorithm to compare probabilities. So to know whether something is true or not, it's mainly for discrete cases, do something or not to do something. So naive Bayes, the probabilistic classifier, in other words, it predicts on the basis of the probability of an object. The reason why it is called naive is because it assumes the occurrence of certain features is dependent of the occurrence of other features of an object, which is not the case in the real world. For example, let's talk about fruits. If a fruit is classified as in terms of its shape, its color, and its sweetness, in the naive Bayes algorithm, for something to be, let's say, an apple, and it has these features of being red, round, and sweet. All of these features are looked at as independent. They do not relate in any way according to the naive Bayes. And because of that, it's naive, because in the real world, such features relate to each other. More on the naive Bayes. The naive Bayes algorithm is applied in artificial intelligence systems such as medical data classification and text classification. For example, filtering between spam emails and normal emails. We have, as an advantage of the naive Bayes, it's a fast and easy algorithm that can be used to predict a class of datasets and classification of multiple classes. As a disadvantage of the naive, as I mentioned earlier, naive Bayes assumes that all features are independent, therefore it cannot be used to learn relationships between features of an object. So let's talk about the Bayesian networks. A Bayesian network is a graphical model that uses probability to determine the occurrence of an event. It can also be known as a belief network or causal network. It mainly consists of a directed acyclic graph and a condition probability table. The directed acyclic graph is called acyclic because it does not go in, it does not make a circle, it does not form a circle. And the reason why it's made like that is so that the underlying probability distribution is normalized to 1 for the network. There's a figure here, having nodes A, B, and C. the figure above shows a directed acyclic graph. A cyclic graph is acyclic so that the underlying probability distribution is normalized one, as I said earlier. A Bayesian network contains nodes representing random variables or hypotheses and edges that connect the nodes as seen from the diagram above. As you can see here, we have the nodes A, B, and C that are connected. A is connected to C, B is connected to C also through edges. From the diagram, like as you can see from the diagram, A and B are the parent nodes of C, and C is a child node of A and B. And because of this, we use such diagrams to show conditional dependency between nodes. Bayesian networks are applied in two probability. Bayesian networks apply to probability concepts, and that is to say joint probability and conditional probability. Joint probability is where two events occur at the same time, but without the dependence of one occurring first, without the knowledge of the other one occurring. They just both occur at the same time, while conditional probability is where one event occurs given another has already occurred. That's what I would call conditional probability. So Bayesian networks are applied in biomonitoring, gene regulatory networks, and image processing because Bayesian networks can be used in these different artificial intelligence systems. Its concepts can be applied mainly, most times used also in hospital and medical places. As here, gene regulatory networks are just about studying how genes are, how they regulate the body. I would say biomonitoring is biomonitoring. I guess it's like all I know is that Bayesian networks are used to study different concepts, different pieces of data, and seeing the dependency, how they relate to each other. So the difference between Bayesian theorem and naive Bayes, the difference between Bayesian theorem and naive Bayes is the fact that the naive Bayes algorithm assumes conditional independence of features, which is also the main reason why it is called naive, as I mentioned earlier. Again, it's a difference because in the Bayes theorem, it does not think so. The Bayes theorem does not conform to such. And this means that the naive Bayes assumes that there is no relationship between any input features, and the Bayes theorem does not conform to such an assumption. That is the difference. Then the difference in the naive Bayes and the Bayesian networks is that the naive Bayes is an algorithm that is used to assign class labels to samples from the available datasets, and such a technique assumes each feature's value as independent and does not consider any relationship between features, while a Bayesian network is a graphical model that represents a set of variables and their conditional dependencies. So, in other words, it's mainly about the fact that naive Bayes ignores the dependencies and the relationships between different features. That's what brings up the distinction between naive Bayes and Bayesian network, and also the Bayesian theorem. These are the references that I used for this data. And I'll start with the dataset that I'm going to be using from the UCI machine learning repository. I'll be basing on the student performance dataset. It has all these different attributes, features of the children that I am planning to use for my AI project. These are the links to the articles and the sites that I used to get information. And thank you for listening. This is also the comparison between, so I got most of my information from. Thank you.